Defining classes. In Dart, a class is a blueprint for creating objects. A class encapsulates data for the object and methods to manipulate that data. Classes are defined using the class keyword followed by the class name and a pair of curly braces. The given code defines a class named car with 3 properties: make, model, and year. There is a constructor that initializes these properties when a new object is created. Moreover, there is a method, displayCarInfo, that prints the information about the car. The this keyword within the constructor refers to the current object's properties, allowing you to differentiate between the object's properties and the constructor's parameters. Constructors: default, named, and factory. In Dart, constructors are special functions that are responsible for initializing the instances of a class. There are different types of constructors: default, named, and factory. In the provided code snippet, we see a class point that has 3 different constructors. The default constructor point takes 2 arguments and initializes x and y. The named constructor point.origin doesn't take any arguments and sets both x and y to 0, creating a point at the origin. The factory constructor point.fromMap takes a map and returns a point object, providing an alternative way to create a point instance, potentially reusing objects or creating a subclass instance. Initializer lists. Initializer lists in Dart are used to initialize final fields of a class before the constructor body runs. They are very handy when you need to ensure that certain fields are set before the object is fully constructed, which is especially useful for final variables that cannot be changed once they are set. In the code, we define a class point with 2 final int fields, x and y. While constructing a point object, initializer lists are used to initialize these fields. The syntax x equals x 100 and x throw is used to assign a value to x, but only if x is less than 100. Otherwise, it throws an argument error. This assignment and check is done before running the constructor body, which doesn't contain any code in this case. This ensures the x and y values meet our criteria as soon as the object is created. Properties and methods. In Dart, a class can have properties and methods. Properties are variables that hold data about the class, while methods are functions that express the behavior of the class. In the provided code, car class has 2 properties, color and year, and 1 method, displayCarInfo. The car class's constructor takes color and year and initializes the car objects with these properties when a new instance is created. The method displayCarInfo displays information about the car. In the main function, an instance of car is created with the color red and year 2021, and its information is displayed by calling displayCarInfo method. Static properties and methods. Static properties and methods belong to the class rather than any individual instances, objects, of that class. This means static items can be accessed directly using the class name without creating an instance. They are useful for representing data or functionality that is common to all objects of that class. In the provided code, MathUtils is a class with a static property pi, which holds the value of pi. It's a constant, meaning the value assigned to pi cannot be changed, and it's static, so it belongs to the class, not to any instance of it. Additionally, there's a static method, calculateCircleArea, that takes a radius as a parameter and uses the static pi property to calculate the area of a circle. Since these are static, you can use them like this: mathutils.pi or mathutils.calculateCircleArea 5.0 without creating an instance of mathutils. Inheritance. Inheritance is a fundamental concept in object-oriented programming, allowing new classes to adopt properties and behaviors from existing classes. In Dart, the extends keyword creates a subclass that inherits from a superclass, enabling code reusability and the extension of class functionality. The code defines a simple hierarchy with animal as a superclass and fish as a subclass. Fish inherits the breathe method from animal and also defines its own swim method. In the main function, an instance of fish is created, and it can call both breathe and swim methods, demonstrating inheritance. Abstract classes. In Dart, an abstract class is a type of class that cannot be instantiated directly and is often used as a base class for other classes. Abstract classes can contain abstract methods without an implementation that must be implemented by any concrete subclass. In this code, we have an abstract class animal with an abstract method speak. Two concrete classes dog and cat extend animal and provide implementations for the speak method. Since animal is abstract, you cannot create an instance of it, but you can use it to call the speak method on an instance of dog or cat. This enforces that each animal has its own implementation of speaking. Interfaces. In Dart, there are no explicit interfaces. Instead, every class implicitly defines an interface containing all the instance members of the class and of any interfaces it implements. A class can act as an interface, and you can implement one or more interfaces by creating a class that implements another class. In this example, Performer is a class that acts as an interface with a method perform. The Musician and Dancer classes implement the Performer interface by defining their own versions of the perform method. When invoking perform, each class provides its respective implementation, thus demonstrating how one can create contracts with interfaces that must be fulfilled by the implementing class. Mixins. In Dart, mixins are a way to reuse a class's code in multiple class hierarchies. A mixin allows you to add the capabilities of another class or classes without inheriting from those classes, providing a form of multiple inheritance. In the given code, swim mixin is a mixin that provides a swim method. The class animal has a breathe method. Dolphin class extends animal and also mixes in swim mixin. Therefore, dolphin instances can breathe and swim. On the other hand, bat only extends animal and does not mix in swim mixing. Hence, bat instances can only breathe. Attempting to run swim on a bat instance will result in a compile time error, demonstrating that mixins offer a selective way to add functionality to classes. Extension methods. Extension methods in Dart allow you to add new functionalities to existing classes without modifying them or creating a subclass. This is particularly useful when working with classes that are outside of your control, like those in third-party libraries or the Dart standard library. In the provided code, we define an extension number parsing on the string class that adds two methods, parseInt and parseDouble. These methods allow any string to call parseInt or parseDouble, parsing it as an integer or a double, respectively. The main function demonstrates how to use these extension methods to convert string literals to numerical values. The output of the print statements confirms the successful parsing. Generics. Generics are a fundamental aspect of Dart's type system, allowing you to write more flexible and reusable code. By defining a generic type, you can create data structures that work with any type, which is particularly useful for collections like lists, sets, and maps. In the code example above, we have defined a generic class box with the type parameter ket_t. This parameter allows us to create box instances that can contain any type specified when creating a box object, e.g. boxInt. The class has a constructor that accepts a parameter of type t, which is the type of data stored in the box. In the main function, we create an instance of box that holds an int, and when we call the open method, it returns the integer value we stored, demonstrating how generics can be used to create flexible classes. Type inference. Dart is a typed language that can infer the type of a variable or expression based on the data it's assigned to, which simplifies the code without losing the benefits of a strong type system. The keyword var can be used to declare a variable without explicitly stating its type. Dart will use the assigned value to determine the type. In the example, number and phrase are variables whose types are inferred by Dart to be int and string, respectively, because of the values they are assigned. This is equivalent to explicitly declaring the variables with their types, as shown in the explicit number and explicit phrase declarations. Type inference reduces verbosity while maintaining type safety. Type annotation. In Dart, type annotation is the practice of explicitly specifying the type of variables, return types of functions, and the types of parameters. This can enhance code readability, error checking at compile time, and maintainability. Let's look at examples of type annotations in Dart. In the code above, the function multiply takes two parameters a and b, both annotated with the type int, indicating that this function expects integer values as arguments. The return type of multiply is also annotated as int, meaning it will return an integer. In the main function, the variable result is also annotated with the type int, clearly communicating that result is expected to hold an integer value. Type annotation helps catch type-related errors during compilation before the code is run. Type checking and casting. Dart is a statically typed language, meaning that types are checked at compile time. Understanding type checking and casting is essential for writing robust and error-free code. In Dart, you can check the type of an object using the is and is operators, and you can cast types using as operator or using explicit casting functions. Future and promises. In Dart, a future represents a potential value or error that will be available at some time in the future. It's Dart's way of handling asynchronous operations, which allows the rest of your application to continue running. Future is much like the concept of promises in JavaScript. In the code, fetchData is simulated asynchronous function that waits for 2 seconds before returning data loaded. The future.delayed constructor creates a future that runs its callback after a delay. In main, we call fetchData and attach then for success, and catch error for handling any potential errors. When the future completes, the callback provided to then gets executed. Stream. In Dart, a stream is a sequence of asynchronous events. Streams are used to receive a sequence of events, like user-generated actions or data changes over time. Unlike future, which returns a single value asynchronously, a stream can deliver multiple values over time. The stream class provides a way to listen to these asynchronous events and respond to them as they occur. The provided code creates a stream of integers from 0 to 99 using stream.periodic to generate an integer every second. The lambda in stream.periodic takes an integer input computation count, which increments on each tick of the periodic timer, starting at 0. The stream is limited to 100 events with the take method. The listen method is used to print out each number received from the stream to the console. This example demonstrates how streams can be used to handle a series of asynchronous events in Dart. Async-Await. In Dart, asynchronous programming is a way to run long-running operations, such as I/O-bound work or network requests, without blocking the main execution thread. The async and await keywords are used to write asynchronous code that looks synchronous, making it easier to read and maintain. Dealing with future. In Dart, a future is an object that represents a potential value, or error, that will be available at some time in the future. It's a core part of Dart's async library, allowing developers to write code that can handle long-running tasks, such as I/O-bound work, without blocking the main execution thread. The code defines a function, fetchUserData, that simulates fetching data asynchronously and returns a future string that resolves after a 2-second delay. In main, we call fetchUserData, which immediately returns a future. We then use the then method to define what should happen once the future completes successfully. In this case, it prints the data. If the future encounters an error, the catchError method is used to handle it. This structure allows the program to continue executing without waiting for the asynchronous operation to complete, thus keeping the application responsive. Dealing with stream. In Dart, a stream is a sequence of asynchronous events. They are a way of handling potential multiple values over time. Streams can be used to process I/O-related operations, such as reading a file line by line or receiving messages over the network. Understanding how to listen to and manage streams is fundamental to leveraging Dart's asynchronous features. This code snippet demonstrates creating a stream of integers using stream.periodic, which emits a sequence of values over time. The periodic stream emits an integer every second. The take10 method is used to limit the number of events to the first 10. The listen method is used to receive each value emitted by the stream. Inside the listener, it checks if the number is less than 100, which will always be true in this case, as the stream is limited to the first 10 natural numbers, and if it is, it prints the number.